example 5 is going to be another retirement problem. A person establishes a sinking fund for retirement by contributing $7,500 per year at the end of each year for 20 years. For the next 20 years, equal yearly payments are withdrawn, at the end of which time the account will have a zero balance. If money is worth 9% compounded annually, how much money is in the account at the time of retirement? And then in part B, what yearly payments will the person receive for the last 20 years? All right, so let's just kind of summarize what's going on here before we start working the problem, okay? This is kind of the whole retirement process, or saving for retirement and receiving the payments. This is the whole process from start to finish, okay? This person opens a retirement account. They save for retirement by contributing $7,500 per year for 20 years. And then they retire. And over the next 20 years, they start pulling money out of that account, okay, during their retirement, and they bring the balance down to zero, okay? So you're trying to figure out, it's got two parts to the problem. Part A deals with the saving for retirement, and then part B, once the person has the nest egg established, it talks about pulling money out of the retirement account once they're retired. Okay, so that's kind of what's going on in a nutshell here. Okay, all right, in part A, how much money is in the account at the time of retirement? Okay, so how did they save for retirement? Well, they contributed $7,500 per year for 20 years, and the interest rate was 9%. Okay, so since this first part, the person is saving money. Okay, this is going back to saving money. Okay, so you have to look at the formulas where you're saving money. Okay, how is the person saving? Is it a one-time deposit? Is it regular deposits? Well, remember, the person is contributing $7,500 every year. Okay, so they're saving money. It's regular deposits, and so you need to use the future value of an annuity formula here. Okay, so we have to go back and use this formula, which we haven't used in a while. So let me go ahead and write it down. Okay, all right, so here's our formula. Okay, again, I'll write that here, where the person is saving money through regular deposits. That's why we're using this formula. All right, so let's talk about what we know, okay, what we're looking for, okay. How much money is in the account at the time of retirement, okay? So we want to know the account balance when it comes time to retire, okay? So we're looking for A, so we should know everything else, okay? P is the amount of each payment into the account, so that's going to be $7,500. R is the interest rate, which is 9%, okay? M is how often the person is making a deposit, which coincides with how often the interest is compounded. Everything is done annually, okay? So M is going to be 1 here, okay? And then T is 20 years, okay? Remember, this problem is broken up into two 20-year segments. During the first 20 years, the person is saving for retirement, and during the second 20 years, or second 20-year period, the person is withdrawing money from the retirement account, okay? All right, so here's what we know, okay? So we can go ahead and plug everything in, okay? So we're going to get A is equal to 7,500 times 1 plus 0.09 divided by 1 raised to the 1 times 20 minus 1 all over R over M. Okay, so that's what it looks like if you plug it in. Okay, it's really nice when M is 1, makes things easier. Okay, let's go ahead and plug this in. This is going to give us the person's balance at the time of retirement. Okay, again, it's been a little bit since we worked with this problem or worked with this formula. Okay, so remember how you want to plug into the calculator here. You're going to start inside the brackets, okay, because it's complicated. You're going to start with the most complicated part, you're going to start in the numerator, okay? So we're going to have 1 plus 0.09 divided by 1 raised to the 1 times 20 minus 1, okay? This will give you the numerator, okay? So there we go. Okay, so now we're going to divide by the denominator, which you could just do in your head as 0.09. All right, so this is what's in brackets, okay? And now we need to multiply that quantity by the 7,500. So times 7,500, okay? This is how much is in the account, and that's a sensible answer, okay? All right, so I don't know why I just wrote down P, because we're looking for A. But the account balance at the time of retirement is going to be this. So let me write the number down and then we can round. All right, so let's go ahead and round, okay? Again, just imagine you get a bank statement or whatever. It's going to have dollars and cents, so you need to round to the nearest cent. So we have 89 cents. Look at the number that follows. It's a 7. So you're going to round it up. Okay, at the time of retirement, the person has $383,700.90. Okay, that is the balance at the time of retirement. Okay, all right. So now part B, the person retires. Okay, so they're going to start receiving payments. Okay, they're going to receive yearly payments out of this retirement account. Okay, so the next 20 years happen. Okay, so the first 20 years, the person accumulated this much money. Okay, now in retirement, which is assumed to be 20 years also, the person will receive money out of this account. Okay, so now the person is going to receive regular payments, yearly payments. Okay, and again, the payments are being received. An annuity is being paid out, okay? So this is going to turn into the present value of an annuity formula, okay? Because you have regular payments that are being received. An annuity is being paid out, okay? Again, you cannot just take this amount and say, you can't just say, okay, I've got 20 years, and you know, I'm receiving one payment a year. You can't just take this amount and divide it by 20. Okay, you can't do that and say, oh, I'm going to get $19,185 every year. That's not how it works. Remember, the person will receive a yearly payment. Okay, there's still money left in the account. Okay, that money that's still there is still earning interest. So you have to use a formula here, and it is the present value of an annuity formula because an annuity is being paid out. Okay, so here we go. Here's our formula. All right, so let's figure out what we know, what we're looking for. Okay, so let's see. Some things have not changed. Okay, we still have the same interest rate. It is still 9%. Everything is still being done yearly. Okay, the person is going to receive a yearly payment out of this account, which coincides with how often the interest on the remaining balance is being accrued. That's going to be one time a year. Time value is 20 years, not because part A was 20 years, but because both segments of this problem happen to involve 20 years. In part A, he was saving money over a 20-year period. Then he retires and he's withdrawing money for the next 20 years. Okay. You know, you could have had a problem where it was a different period of time for part B. So just be aware of that. Okay. All right. So now it's coming down to P and PV. Okay. We got to decide what we're looking for and which one we know. Okay. So you're trying to figure out for this person how much they're going to receive. Okay. What is going to be the payment to them? Okay. So we're actually looking for the payment here, the payment to the person. Okay. Present value. At the time of retirement, how much is in the account? Well, it's what we found in part A. Okay, the present value of the account is this. Okay, that's how much it's presently worth, and then you start withdrawing money from it. Okay, so let's go ahead and plug everything into the formula and solve for the yearly payment the person is going to receive. Okay, so let's plug everything in. All right, so it's going to look like this. All right, so here we go. All right, so we need to solve for P, okay? Again, P is multiplied by all this stuff, okay? So we need to figure out what this quantity is, and then we can go from there, okay? So we're going to have $383,700.90 is equal to P times, let's figure out that quantity, okay? So let's plug it into our calculator, okay? Again, you want to start with the numerator. We're looking in brackets here, okay? We're going to start with the most complicated part. So we're going to do 1 minus 1 plus 0.09 divided by 1 raised to the negative 1 times 20. Okay, make sure if you have an older calculator, you're putting that exponent in parentheses. Okay, that's the numerator. You're going to divide by the denominator. This is going to give us what is in brackets. Okay, so let me write that down. Okay, and now if you want to isolate P, okay, since you're multiplying P by this quantity, now you just need to divide it off. Okay, all right, so whatever you do to one side, you got to do to the other. All right, okay, so that will give us our P value, okay. This will cancel on this side and leave you with P, okay. All right, so let's go do it, okay. Again, I already have this denominator in my calculator, okay. So you can just go ahead and punch in the numerator, so $383,700.90, and then divide by the previous answer if you don't want to retype it in, okay. If you do retype it in, you need to carry all the digits, okay. And there you go. Okay, so let me write this down. All right, so there is the yearly payment to the person. Okay, so we need to go ahead and round to the nearest cent. Okay, so we have 8 cents. Look at the number after. It's a 1, so it's going to stay 8 cents. Okay, the person will receive yearly payments of $42,033.08. Okay, and that is a reasonable answer. Okay, for some people that's like a yearly salary to them, so that is a reasonable answer. Okay, so that is how you do this problem, and it was a great problem because it kind of showed you the entire retirement process where you first save. Okay, you come up with a quantity or an accumulated amount that you've saved for retirement, and then you start withdrawing money from that account, and you can see how much you can withdraw, you know, every year, every month, or whatnot. So it's a pretty nice problem to know how to do for just life in general.